Probability is a rather tricky subject to define, and people often talk about the probability is the same as the chance of something happening, or they talk about the odds of something happening, and the definitions tend to go around in circles. And what we normally use are one of three different definitions. The first one is what's called the classical definition, and this is also sometimes called the equal likelihood method. And this applies when you're doing an experiment with a number of outcomes and they've all got the same chance of happening. So for example, if I roll a die, I can get a 1, a 2, a 3, 4, 5 or a 6. There are 6 possibilities, and because the die is symmetrical, it's a perfect cube, and we don't worry about little blobs on it that might disrupt it and make it slightly uneven. We assume it's a perfectly normal cube, then each of those numbers is equally likely to come up. And so each one has the probability or the chance of 1 out of 6. So the probability equals 1/6 for any one of those items. They've all got the same chance. However, some things don't have equal probabilities. If we think, for example, about tossing a drawing pin instead of a die, the drawing pin can land this way up, or it can land that way up. And they are not symmetrical. They're not equally likely because it's a very unsymmetrical object. So what we have to do in this case is what's called the relative frequency definition. Where we actually just do the experiment lots and lots of times. We toss this drawing pin a number of times and we find out what fraction of times it lands pins up. So suppose we did 100 tosses of this, and we might get 32 of those and 68 of those. So out of the 100 times, the fraction of times that the pin has landed point up is 32. So we would say the probability of pin being up equals 32 out of 100, which is 16 out of 50, and we can simplify and we get 8 out of 25 as the simplest fraction. Or if you want to use a decimal, we just get 0.32. Probabilities can be represented as fractions or decimals or even percentages. We could call this 32% as well. They're all equally valid. This is often used where there's long historical records. For example, weather. What's the chance that it's rain or sun each day? Well, we can look back over many years and we can count all the days and see how many of those days were rain, how many were sun. We must always remember that just because there are 2 possibilities doesn't mean that it's 50-50 chance. Just because it's pin up or pin down doesn't mean they're equally likely. It's a very common error. I can either win the lottery or I don't. Just because there's 2 possibilities doesn't mean they're equally likely. We mustn't always apply this method when it's inapplicable. Now, some events we can't handle in either way because they're not equal likelihoods and we don't have a lot of data historically to go on. Things, for example, like football matches or general elections. So the third definition we might call the subjective definition, and this is basically where we take a guess. Let's think about a football match or football series. What's the probability that Man United will win the league in the next season? Well, we can look back at the past. We can see how many times they've won the league in the last 50 years. But these are not really the same experiments because it's a different Man United team now, it's different opposition. So they're not really comparable. And we can't say well, either it does win or it doesn't, so it's 50-50. We can't use that method either. So this third case, football events, elections, one-off competitions, we just have to take a guess, and we can make an educated guess at a number between 0 and 1, which somehow represents how confident we feel. So we might think, well, there's however many teams there are in the league, but we think Man United are one of the best ones. So we might say, I think it's 0.4. But that doesn't really have any mathematical significance. It's just my hunch, an expression of my degree of belief. So those are the three different ways that we can define or measure probability. And next time we go on to look at how we can combine them for more complicated events.